Hello students, welcome to Unacademy. How are you? So happy Engineers Day to all of you. And today we are going to talk about the pressure measurement. We are continuing our discussion on pressure measurement. So in previous class we seen that what is this piezometer basically and what are the limitations of piezometer, and those limitations of piezometer is going to overcome with the help of YouTube manometer. That also we seen, but there are some limitations of YouTube manometer also, correct? And because of that we are going to do some more modifications in YouTube manometer, or you can say some more different type of manometers we are going to discuss in this particular chapter. So today we will complete this particular chapter, means pressure and its measurement, right? So many of you know about me and many of you don't know about me. So for those who don't know about me, for those people I can say I am well known faculty in India. Name is Shivam Dixit, नाम तो सुना ही होगा. Okay, so I did my MTech from NIT Calicut in thermal science. After that I got chance to work with Indian Oil Corporation Limited R&D as automotive research officer, and from last 9 years I am guiding the GATE and ESE aspirants, and up to now I have guided more than 50,000 students. Out of that, many of my students are secured single digit and double digit rank. So this is all about me. But one more very important news I want to tell you, very important information I would like to tell you here, that one special discount is going on Unacademy Plus. If you want to purchase, if you want to subscribe for Unacademy Plus platform or iconic platform, or light play, any type of platform you want to subscribe, then 20% off is going on, and this 20% off is going to over by tomorrow. Don't forget this. Tomorrow this 20% off is going to over. So if you really want to get into the this subscription, or if you want to give a new edge to your preparation, right? And even here also I'm teaching pretty good only, right? Because I'm a very good faculty, very handsome faculty also. Sometimes people are not appreciating me, then I am appreciating myself, right? So basically so even though we are teaching here also, and even our complete team is coming, and we are going to teach in YouTube, and we are going to help our students who cannot buy the subscriptions. But if you still want to get some edge and you don't have problem of money, and after paying money the seriousness is also coming. That is the true thing. Yesterday one student asked me that, sir, what is the difference in Plus and this YouTube classes? So I said that it's mostly it is that that systematically you are getting the things in Plus platform. You are getting systematically things, because some of the faculties are there who are not coming to YouTube, and even though whenever we are coming to YouTube, then also it is not systematically from first day to last day. Means okay, some sessions are there, maybe in between some gap is there, again some sessions are there. And here the most important part is that here people are not serious. Whenever you are paying something, whenever you are taking Apple phone, then you always try to respect that, because it's very costly. But when you are taking some local phone, then you are not giving that much respect to that. Arey, theek hai, toot jata, I will purchase something new. It's kind of thing is there, right? So in YouTube many things are there, right? And if you want to continue your preparation with this, you can do. Actually it's a sufficient, I would not say it's not sufficient, it is definitely sufficient. Lot of lectures are there for me, my lectures are there, other faculty lectures are there, so you can definitely do that. But still, whenever you are paying something, then definitely some seriousness will come into the picture, right? So those things are there. If you really wants to get into this particular subscription and all, then 20% off is going on. That is on Shivam 101. You have to use code Shivam 101. And okay, and one more information, that from 22nd of September, from this 22nd of September, my fluid mechanics course only, like complete course on fluid mechanics, is going to launch on Plus platform, right? So if you are a Plus student, if you are a plus student, then I would like to suggest you to go in a app and like my follow me, so that you will get the proper updates, and join me on 22nd. We'll definitely do something big, don't worry. For the student who are not in plus, basically for those also, one very good news is there, that from 19th September onwards, I am going to start one another course, right? That is a concept through questions series of basic thermodynamics. Here I'll discuss all the concepts which may come in upcoming exam, and other than this discussion will be through the questions. So first I'll show some questions, and then through that questions we will try to discuss concept also. This is from 19th September only, after 2-3 days, and that is in Unacademy platform only. Unacademy, but free classes there, that is free special classes are there, and the timing is going to be like morning 9:30, right? Time is also decided here. This time is also 9:30 a.m. to 10:30 a.m. 10:30 a.m. right? So this is 1 hour class, and it will continue for 20 days. So in 20 sessions I will complete basic thermodynamics, and if you are not that much good in thermodynamics, don't worry about it. If you are attending this session, you will be good in that, as well as some very good number of problems we are going to solve. I can guarantee you that even if you don't know much about thermodynamics, then also you can attempt 70 to 80% of question, if you don't know the basics of thermodynamics. If you know some basics, then definitely you are going to secure full marks on thermodynamics. So this is basically the thing, this is basically the information. So 22nd date you cannot forget, and this 19th date you cannot forget, correct? And this is a free session basically. Clear hai? So as you all know, the some criterias are there in YouTube to attend my classes. The very first criteria is there: whenever you are coming to my class, you have to like the session, right? And if you're not subscribed the channel, then you have to subscribe the session. Sorry, everyone is saying this one only, but here one more thing is that you have to give respect to your faculty. You have to give respect to your faculty. So you have to wish good afternoon, good evening, whatever it is there. Obviously it is good evening, so you can wish good evening to me. You have to wish, not you can, you have to wish, right? Then only you will get the best from me. Then only you are going to get best from me. Clear hai? Clear hai? So basically today we'll discuss that what are the limitations in YouTube manometer, and why we are using some other type of manometer like single column manometer or inclined column manometer, and what is the differential manometer. So all these things we are going to discuss. So, and one more rule is there in my class. To attend my class is that you have to go to the session, you have to go to your channel, whatever you are belonging from, and you have to write that class is live. Every day I am saying this one, but you people are not doing this. That is a problem. Okay, so just like the session, subscribe the session, and whatever you want to do it, no problem. Acha, one more thing before starting. Today is engineers day, our day, and one एक problem है मुझे यार with some guys, not you all, right? With some people I have one problem, like I want to share this. Many time in my physical classes I used to say this, but sometimes people are following this, sometimes they are not following it, right? So what is the problem, right? Up to here we did, right? Study class we did up to here. What is the problem actually? See, today is the engineers day, and we are the people who are basically creating the words. We are making our word beautiful. Whenever we are feeling hot, then we can use the fan, we can use the AC. Whenever we want to go somewhere, we can use car, bike and all. Now you see, means whatever our work is there, right? Whatever our some work is there, and the efforts are decreases, efforts to do any work is decreases because of this engineering, because of the engineers. What I personally feel, beta, what I personally feel that we all should have to proud to be engineer. We all should have proud to be engineer, but most of the people are not doing this. You know, जानवरों में और हम इंसानों में क्या डिफरेंस है? जानवरों में सी our lifestyle is completely different. Miss, I'm talking about human being. Human being lifestyle is completely different. They are in a house. They are constructing their house for them. They are constructing roads. They are like they have make one system to live. They have make to some system to live. But if you talk about animals, if you talk about जानवरों की बात करोगे तो क्या होगा? They are simply living their lives. They are simply living their lives. Right? They don't. There is no any structure for their life. You know why? Because वहाँ कोई structure बनाया ही नहीं. Means there is no engineers. That is the difference in human being and animal. In human being community, engineers are there. That's why it seems like this. That's why we are human being. हम जानवरों से अलग हैं because of engineers. हम जानवरों से अलग हैं because of engineers. And we must proud that we are engineers and we are creating the words. We are the shaper of the world. But one problem is there. One problem I have with you people, not you people, some of the people who are always making fun of engineering. I'm very much serious about this. I've seen many bloggers are there, many YouTubers are there, many people are there who always try to make fun of engineers, who always try to make joke on engineers that they don't have job, they are doing this one, they are not studying in college, this one happening, that one happening, they are not doing experiment, what blah 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 blah. Lot of jokes are there on engineers. I am completely against this, and I do not have problem if someone is doing this. I have problem when an engineer doing this. You know, जो भी ये joke बना है ना, जो भी jokes हैं, जो भी blogs हैं, जो भी ये channel में सब ये सब चलता है नौटंकी, right? यार ये what I personally seen that it is 70 to 80% are engineers only. 70 to 80% are engineers who are bloggers, who are YouTubers, or who are something else, right? They just try to make fun of engineering. They just try to disrespect the engineering. Please don't do this. If you are not going to respect your profession, then how can you expect from others? Nowadays people are saying that sir engineering का कोई इज्जत नहीं कर रहा, engineers का कोई इज्जत नहीं कर रहा. It's the reason is engineer only. They are only making such jokes. They are only making such fun videos and all this nonsense, right? So my personal request to all of the engineers, I personally request that please don't do this. We should have to respect our profession. No doctor is going to make the fun of their profession. No CA is going to make the fun of their profession. No lawyer. Have you ever seen any lawyer is making fun of their profession? Have you seen any CA who was making fun of their profession? No, it's only engineer. That is the problem. So I respect all the engineers that please respect your profession. If you are not going to respect your profession, then definitely you cannot expect from others. जो काम तुम खुद नहीं करते हो, तुम कैसे सोच सकते हो कोई दूसरा करेगा? First, you have to respect. If someone is saying something about engineering, then you just have to oppose them. And you just have to at least say some decent answer. नहीं भैया ऐसा कुछ भी नहीं है. When it's come to the job, I can understand it's difficult nowadays to get job. Why? Because you have unnecessary pressure. When a BA student is there, right? When a BA student is there, then communities, when he pass out BA or he pass out BSc or any other thing, then people are not expecting him that he should do job. Even though he is not doing job, no one is going to ask, ki beta, why you are not doing job? No one is, but for engineers, everyone is going to ask, why you are not doing. And the best part of being engineer, you know what? Struggle is there, I understand, beta. You are also struggling, I also struggled, many of engineers are struggling. But the good point is your senior also may be struggling. The good point is this is struggle is there for initial few years, but every engineer is going to be settled somewhere, not necessary to be engineering only, but somewhere he is going to settle. आप देखिए मे बी आपका जस्ट इमीडिएट सीनियर जो है ही मे नॉट सेटल इन देयर लाइफ, मे बी अप टू नाउ your friends are not settled in your in their life. But you just tell me how many of you engineers you know that he did engineering, you know, some 5-6 year back, but still he did not get some decent job, right? It is taking time, I can understand, right? It is taking 1 year, it may be for some people 2 years, even some people for 3 years also taking. Some people are starting their job with very minimum prices, right? And they are struggling initial few years off in their job. But after few years, what is happening? 5-6 years, after 5-6 years, what is happening? They are doing something decent job. They are improving the society. They are doing something good for the society. This is the beauty of being engineer. Please respect this engineering. Is it true for all other professions? No. Suppose one BA student is there or BSc student is there. Is 95% of BA students, BSc students are, you know, doing good in their life? But okay, here struggle is there, beta. Struggle, I understand. Even nowadays, struggle is somewhat more. But please respect. Okay. Okay. Very good evening to all of you. Very good evening. Siddharth, Deepak, Aditya, Datta, Jay, Naveen. So from today onwards, everyone is going to respect their profession. Clear hai? Okay. Let's start, beta. Let's start. So yesterday class we seen that what are this U2 manometer, right? What is this U2 manometer? And this U2 manometer have one disadvantage. U2 manometer have one disadvantage. What is that disadvantage? That if a person is like engineer or if person is like a scientist or something, for them no problem at all. But the person who is a layman type of person, like he is just working or, you know, layman type of person, so for them it is very, very difficult to measure the pressure with the help of U2 manometer. Sir, how? Sir, how? Please listen here. I am showing this. Suppose this U2 manometer you are using. Suppose yesterday we use this one. You are using this manometer, right? There is any single formula for U2 manometer? No. For every manometer you are using is different. For every manometer you are using what? You are basically using the same like hydrostatic law. You are using basically a law. There is no single equation. For every manometer, every U2 manometer, different equation is there. You are getting my... And another point is that here how many reading you need to take? How many reading you... This is one unit. This is one reading you have to take. Then this is another reading you have to take. Then this is another reading you have to take. Then this is another reading you have. How many reading you have to take? 4 readings you have to take, my dear student friends. 4 रीडिंग लेना पड़ रहा है यार. मतलब आप सोचो एक लेमैन जिसको बहुत ज्यादा हाइड्रोस्टैटिक लॉ नहीं पता है, कुछ भी नहीं पता है, उसको 4 डिफरेंट यू नो रीडिंग्स मेजर करना है. देन दे हैव टू मेक वन फॉर्मूला and then they have to put these values in formula and then they have to find out the value of pressure. Is it easy for them? No, it's not easy. It's actually not easy practically for a layman person. He will definitely do some mistakes. He will definitely do some mistake. Clear hai? Shiv Pujan Pal, very good. Good beta. Right. So basically what is happening? Basically what is happening that here it is very, very difficult to measure 3-4 different units and making one formula and putting in this formula. It is very, very difficult, my dear student, for a layman, for a normal person. So, and if suppose only one reading is there and one formula is there, then easily we can do. So basically this single column manometer is basically using, it is a modification of U2 manometer only, but we are using such arrangement so that even a layman or even a normal person can use this, and just by measuring one reading he can find out the final value, he can find out the pressure value. Basically that is the main motto of single column manometer, single column manometer. So have you got the answer? Have you got the answer that what is the limitation of U2 manometer? What is the limitation of U2 manometer? Tell me, right? U2 manometer, in U2 manometer, more than two or more than one readings you have to take, right? Many number of readings you have to take, and you have to apply the basic law in every single problem, right? So for normal people it is not that much convenient, right? So that's why for normal people, for convenient purpose, we are going to launch another very important manometer, that is single column manometer. That is single column manometer, right? Now so U2 okay, how this single column manometer basically work, that we need to understand here. Okay, the very first I am going to tell you that how it will be look like. First I am going to tell you how it will be look like. So basically it will be look like this one. Please listen here carefully, प्लीज लिसन हियर केयरफुली. देखेंगे इधर कैसा दिखता है ये. इसमें क्या होगा, दो चीजें हैं. एक रिजर्वायर होगा. क्या होगा, एक रिजर्वायर होगा. मतलब व्हाट इज दिस रिजर्वायर सर, आई डोंट नो. ओके, यू डोंट नो, वेरी गुड. यू डोंट नो, दैट्स व्हाई आई हैव वैल्यू. मेरा वैल्यू तब तक है जब तक तुमको आता नहीं है. जिस दिन तुमको सब कुछ आ जाएगा उस दिन तुम मेरा क्लास में आना बंद कर दोगे. हैं, कहोगे अरे सर का क्या ही पढ़ाते रहते हैं, हमको खुद ही सब कुछ आता, मैं खुद ही इतना टैलेंटेड हूँ. ठीक है. This is basically what, this is basically single column manometer. This is basically single column manometer. मतलब ये सेम ही है लेंथ, ऐसा मतलब मत करना. क्रॉस सेक्शन एरिया सेम ही है, थोड़ा सा हाथ से बना रहा हूँ ना इसलिए ऐसा हो रहा है. ये सिंगल कॉलम मैनोमीटर है. अब इसमें देखो क्या है, here basically two things are there. This the whatever रिजर्वायर का मतलब होता है जो थोड़ा बड़ा साइज में है कंपेयर टू. देखो ये इसका क्रॉस सेक्शन एरिया, लेट्स से दिस क्रॉस सेक्शन एरिया इज स्मॉल ए, दिस क्रॉस सेक्शन एरिया इज स्मॉल ए, and this cross section area, let's say capital A. I'm writing this cross section area is capital A. Okay, this cross section area capital A. Now this capital A is much bigger than small a. It may be more than 100 times, more than 100. Means if it is one let's say it is 1 centimeter for example, or 10 centimeter for example, right? So if it is a 10 centimeter, then it will be 1000 centimeter square. This 1 centimeter square, then it is a 100 centimeter square minimum. It may be 200 times, it may be 300 times. If it is big, then it is better reading you will get. How you will get to know? You will get better result, right? So initially this is very much important. If you go and read the books now, maybe you will not understand the core thing, that what is the single column manometer, why what is the benefit, and very important here also some limitations are there. हर जगह लिमिटेशन है, दुनिया में कोई परफेक्ट नहीं है. अगर तुमको लगता है कि सर मुझसे नहीं हो पा रहा है, मैं बहुत बेकार लड़का हूँ, मैं एवरेज स्टूडेंट हूँ, बिलीव मी, नो वन इज परफेक्ट इन दिस वर्ल्ड. नो वन इज परफेक्ट एक्सेप्ट मी. केवल मैं परफेक्ट रहता, मैं. So initiate is something like this. So initially pressure in both the column is same, right? So here it is something like this. So here केवल मैं परफेक्ट है भाई, मैं परफेक्ट है. सर आप हमेशा अपनी बड़ाई करते रहते हो, मैं ऐसा, मैं वैसा, मैं वैसा. भाई दूसरा कोई करता नहीं तो क्या करूं, मैं खुद ही कर करके खुश हो जाता. इसमें प्रॉब्लम क्या है? अगर आपको लाइफ में खुश होने के लिए कुछ भी करना पड़ रहा है, सब लोग खुशी के लिए कर रहे हैं, खुशी के लोग पैसा कमा रहे हैं, खुश रहने के लिए पैसे कमाते हैं, खुश रहने के लिए जॉब करते हैं, खुश रहने के लिए सब कुछ करते हैं. अगर मुझे सिर्फ छोटा सा झूठ बोलना पड़ रहा है मेरे खुद के लिए, तो ये प्रॉब्लम क्या है यार? मैं खुश रहूंगा, ये इंपॉर्टेंट है कि मैं अपने मियाँ मुट्ठू बनने में क्या है, जिसको जो सोचना है सोचे, आई डोंट बॉदर, right? So now you can see that here is also PATM, right? Here is also pressure is what basically PATM beta. Here is also pressure is PATM. Here is also PATM. That's why same level is there. That is basically same level. Clear hai? This point is clear. Ye initially it will be look like this one. Initially it will be look like this one. So initially the single column manometer will be look like this one, where A is very big than small. ठीक है, क्लियर है? अब सर ये जो आपने बनाया है, हाउ यू आर गोइंग टू यूज दिस, how you are going to use this, basically that we are going to discuss. Okay, let's come to the next one. In this slide I'm going to show that how we are going to use. For example, suppose we have one, this is a container, right? In this container, this is a container, and now here is, let's say, pressure is P, lesser is P, this is a higher pressure, higher than atmospheric pressure. So I just want to measure this pressure P. I just want to measure this pressure P. ठीक है? So I am going to use single column manometer. Now this is a what rhom. This is what rhom means, manometric fluid, generally mercury, but it may be different or different also in different cases. What are the cases? I will tell you. Who will tell you? I will tell you. Okay, don't say that mercury is only used as a manometer. In different cases, different requirements are there. In some cases, mercury is not fulfilling the requirement. I will tell you that condition. Number of times they asked. Even one of the student went in bark, right? And he was discussion was going on this. So that interviewer asked that. Like why manometric fluid is why mercury is used as a manometric fluid, best manometric fluid. So he gave that example. Then he said that this is the only best manometric fluid. Unfortunately, he said yes. Then the interviewer asked that no, you are saying wrong. You just think and tell me. It is not. Is it applicable everywhere? Then luckily he was my student. So he said no, sir, it's not applicable everywhere. Most of the cases mercury is suitable, but in some of the cases mercury is not suitable. What are those cases? तो क्या तो मेरा स्टूडेंट तो सेलेक्ट हो गया बाहर में, अभी हैदराबाद में है वो, है हैदराबाद में ट्रेनिंग कर रहा है वो, है तुम भी अगर मेरे स्टूडेंट बने रहोगे तो पक्का तुम भी सेलेक्ट हो जाओगे. ओके, लेट्स स्टार्ट. तो अभी देखो इसको ऐड करते हैं. तो अभी क्या करेंगे, आई वांट टू मेजर दिस प्रेशर. सो व्हाट आई एम गोइंग टू डू इज लाइक आई एम गोइंग टू ऐड हियर, आई एम गोइंग टू यूज हियर the single column manometer. Which manometer? Single column manometer. Which column? Single column manometer. अभी हम यहाँ पे सिंगल कॉलम मैनोमीटर यूज करेंगे. सर यूज करो, कोई दिक्कत नहीं है. कोई कुछ कहे हमको बताना, ठीक है, तुमको बता देंगे, कुछ नहीं कहेगा. ध्यान से सुनना. देखो यार, एक बड़ी प्रॉब्लम हो रही है आजकल बच्चों के साथ. मैं आज तुमको बताता हूँ, क्योंकि ये प्रॉब्लम्स क्या है ना, मुझे लगता है कि पढ़ाई का जो प्रॉब्लम है, या फिर मतलब जो भी प्रॉब्लम्स हम लोग समझते हैं कि हमें फ्लूइड मैकेनिक्स नहीं आता, हमें थर्मोडायनामिक्स नहीं आता, हमें ये नहीं आता, हमें वो नहीं आता, इन सबसे भी बड़ी प्रॉब्लम्स हैं. एक सबसे बड़ा प्रॉब्लम क्या है कि whenever you used to watch the reels, you used to watch the TikTok and this one all blah blah blah, इससे दिमाग में बहुत फर्क पड़ रहा है. क्या फर्क पड़ रहा है मैं बताता हूँ. टिकटॉक क्या हो रहा है, टिकटॉक is banned, I think. So YouTube shorts or something. In this, what is happening, one person is there, right? He is doing some hard work, something is doing, or he is studying. Then म्यूजिक चेंज होता है, कैमरे का रोटेशन होता है, और इमीडिएटली वो IAS ऑफिसर बन के आ जाता है. पीपल वॉन्ट दैट मच फास्ट. दैट इज द प्रॉब्लम. तुम्हारा मेंटल स्टेट भी वैसा ही होता जा रहा है. एक तरफ दिखाया राजकुमार राव है, राइट? एक तरफ दिखाया राजकुमार राव है, कुछ तो कर रहा है, मतलब एकदम बहुत स्ट्रगल कर रहा है. देन इमीडिएटली म्यूजिक चेंज होता है, कैमरा चेंज होता है, राइट? और सीन चेंज होता है, और फिर आता है क्या, वो IAS ऑफिसर बन के निकला हुआ है, और क्या तेरा इंतकाम देखेगी समथिंग काइंड ऑफ गाना बजता है. क्या ऐसे ही ना तेरा इंतकाम, आई डोंट रिमेम्बर एग्जैक्ट सॉन्ग बट कुछ ऐसा करके आता, तो इसको लगता अरे अरे देखो अभी 10 सेकंड पहले स्ट्रगल कर रहा था, 10 सेकंड बाद में वो एकदम आईएएस ऑफिसर और लोग रिस्पेक्ट कर रहे हैं, 4 बॉडीगार्ड चल रहे हैं। तुमको लगता है सब 10 सेकंड में हुआ है? बीच वाला कट है बेटा 3 साल, बीच का 3 इयर्स तो कट कर दिया। समझ रहे हो? ये जो इंतकाम वाला जो सोच रहे हो ना, टाइम देना पड़ेगा, आएगा बट टाइम देना पड़ेगा, राइट? सो माय सजेशन इज दैट ये जो चीजें हैं, बच्चे यहाँ पे आते हैं, राइट, उनको लगता है अरे सर ये क्या बोलो, तो जल्दी जल्दी कंटेंट पढ़ाओ, जल्दी जल्दी कर दो, जल्दी जल्दी हो जाए, जल्दी सिलेक्शन हो जाए। इतना जल्दी भी करने का क्या जरूरत है? थोड़ा समझ लो, थोड़ा चीजों को परफेक्ट बनाओ, राइट? क्लियर है? डू यू नो डॉक्टर मुरलीधरन? अरे हाउ कैन आई फॉरगेट हिम यार, मितेश, हाउ यू नो डॉक्टर मुरलीधरन सर? He taught me 2 subjects. Two subjects. He taught me 2 subjects. He was one of my favorite teacher. Yeah, he was one of my favorite teacher. How you know that, Mitesh Prajapati? How you know that, Mr. Dr. Muralidharan sir? अच्छा देखो, ओके मैं कभी और बताऊंगा, बिकॉज आज थोड़ा ज्यादा बातें हो रही हैं, राइट? तो आज थोड़ा ज्यादा बातें हो रही हैं। नॉट टुडे, सम अदर डे आई विल टेल यू वन स्टोरी। सरप्राइज था मेरे लिए बेसिकली। ओके, प्लीज लिसन हियर। सो दिस इज इनिशियल लेवल ऑफ Hg mercury, initial level of mercury. Okay, this is the initial level of mercury beta. Just a minute, sir please reply me sir। क्या पूछा है बेटा, मैंने देखा ही नहीं। I am studying now in thermal science. Okay, you are in NIT Calicut. Okay, Mitesh is in NIT Calicut. Okay, good. Happy Engineers Day, thank you sir। You told in 5th lecture there is a good news for YouTube GATE learners, announce in 10th. Yes, I announced. No, I did not announce, I forget to announce, I think. Okay, today I announce who is that? Naveen Sharma. Naveen, one very good thing I am going to announce today, very good, very big news I am going to announce today। अच्छा वो मेरे पेट में बात पचता नहीं है तो मैं बताऊंगा जरूर। क्या हुआ कि few year back, I think in 2017 or 18, right? 2017 or 18, in one batch, one girl was there and she was studying, right? She was my student basically. So once batch is over, during batch she didn't tell me anything. After batch is over, then after that one day she told us, sir you are from NIT Calicut? I said yes I am from NIT Calicut। Sir you know Shobhan CV sir? How can I forget? He is one of the top most faculty, not only in India, in whole world. If you in nanotechnology and thermal sciences, if you see the top 10 faculties or top 10 researcher of complete world, maybe his name will be there. He's one of the top most person, and he have in more than 20-30 patents are there, and more than 100-200 research papers are there, that too also international journal। वो तो मतलब he is another level person यार। how can I मतलब forget him? So she said that sir he is my father। I was surprised like anything। her name was I forget the name, so she told that he was my father। मैं पागल हो गया, मैंने कहा तुमको यहाँ आने की क्या जरूरत है भाई? Why you came here in this coaching? हैं? अरे भैया, you are sitting near to sea, you are sitting near to river, गंगा रिवर के पास बैठे हो। वहां से चल के आते हो एक तालाब में पानी पीने के लिए. Ganga, you are, let's say you are you are sitting near to the Ganga river, and then after that you are coming to from Kerala. She was from Kerala. She came Kerala to Hyderabad for studying, and that too also from me. हैं? अरे मैं तो कुआं है भाई, वो नदी है, गंगा नदी. So at that day, one thing I got to know, one conclusion I got to know. मैं दुनिया को पढ़ा सकता, लेकिन मैं 2 लोगों को नहीं पढ़ा सकता. Right? I cannot make her like understand 2 people. Whenever you say that this concept is difficult for me, just tell me, I will make it simpler for you. But 2 people are there who are not listening me. One is my son. He is only 2.5 years old, but still he is not listening me. And another one, I will not say the name. Another one, right? His mom, basically, my son mom. These 2 people are there, उनको तुम कभी समझा नहीं सकते. Okay. So basically here what is there? अरे यार तुम लोग बातों में लगा देते हो. Don't waste my time यार. Don't waste my time. Don't waste my time भाई. Don't waste my time. सर आप वेस्ट कर रहा है, मैं कहाँ टाइम वेस्ट कर रहा. Okay, Datta. Now please listen here. So what is happening basically? That here some fluid is there, right? And initial level is this one. Initial level. Now when we will attach, let's say this is a green color one. When we attach, then this will enter here. Obviously, the pressure is more. Then what will happen? It will be compressed. So now what is going to happen is that now this will go up to here, let's say. So this is a delta H. This is basically what? Delta H. It is going down delta H. And it is going delta H, but here what will happen basically, in this side, it will reach somewhere here. Area is less, na? It is basically, this is delta H, and this is, let's say, H. This is basically it. Now please listen here carefully. Fulfilled learning from you. Okay, Kalam. Thank you. Now please listen here carefully. Arey sun lo bhaiya, sun lo. Please listen here carefully. Now what is happening? That whenever you are going to attach this, then this level will decrease, but very little bit level will decrease, because even though very small level is decreased, only delta H is decreased, but volume displacement is huge because area is more. So basically, if I apply the law of conservation of volume, because incompressible fluid, no? So if I apply a law of conservation of volume, then what I can say that delta H, kitna volume displaced here? What is the volume displaced left hand side in reservoir? What is the volume that is displaced in a reservoir? That is delta H into capital A. Delta H into capital A, and same volume is going to displace in another limb. अरे जो volume इधर displace होगा वही तो ऊपर जाएगा ना. इधर देखो, right? So it means that, and that is H basically. So this is going to be like A into H. Correct na? So now you can see that area A is very big. A is very big than A. Small a. Capital A is very big than it means that delta H going to be very small than H. Now please, first I am going to write the exact equation, right? First I am going to okay, let's start with the P. Okay, let's start with the P. Let's say this height is H1, this height is, let's say, H1, and this height is, let's say, H2. No problem. This side is H1, this side is H2. Now start from P. Beta. Champak beta. Start from P. Now I am going downward. Downward means positive. This fluid density is rho. So here it will come rho G H1 प्लस डेल्टा एच, H1 प्लस डेल्टा एच। अरे इनिशियल लेवल ये है, बट अभी तो लिक्विड क्या है ना, थोड़ा एक दो हटा देता हूँ इसको, थोड़ा सा भी ना ब्लू वाला, तो थोड़ा सा सही लगेगा, ठीक है। नाउ H1 plus delta H, H1 plus delta, now I reach here, now I'll jump from here to here, I'll jump from here to here, I'll make another color so that you will comfortable. ये यहाँ से यहाँ jump कर गए, then we'll move upward, upward means minus rho m g H2 plus delta H is equal to 0. I am writing. Why I am 0? Because this is a PG, gauge pressure I am calculating. Clear है? इस इक्वेशन में अगर किसी को प्रॉब्लम है तो अब भी पूछ लो. If anyone have any problem, please ask. Please ask. Please ask. Yes, correct. Anyone have any confusion, please let me know बेटा. ये इक्वेशन में कोई डाउट तो नहीं है? If anyone have any confusion in this equation, please let me know. Thank you बेटा, thank you. सर एक बार वापस समझा दीजिए. ओके अमरजीत, प्लीज लिसन हियर केयरफुली. हमने क्या किया? नाउ हियर यू कैन सी दैट this is basically, initially it will be look like this one. Initially when you are going to attach here something, then this will be displaced na, this level will decrease, this level will go down. When this level will go down, and this level will up, this side it will be up, this side it will be down, but left hand side it will, in reservoir it will go very little bit down, only delta H it will decrease, whereas here it will be huge. This initial height is given, this is, let's say, known, this is basically H1. Clear hai? So it is going delta H down, but here it will be H2, it will go up, because area in second level area is less. Now please listen here carefully. So from here if I start, then PG I am writing, gauge pressure. Then from here we are, this is level na, from here I am moving how much? I am moving H1 plus delta H, H1, so rho G H1 plus delta H. When I reach here, then I'll jump from here to here. Again I'm moving upward means negative, means rho m, here manometric fluid is there, this is rho m G H2, this is H2 plus delta H, H2 plus delta. Clear hai? From here you can calculate PG value. This is the exact, whatever answer you will get from here, that will be exact. But again same problem is here also, you have to measure number of things, and you have to measure delta S also, you have to measure H2 also. So this is a problem for a layman person. So what I'm going to do is, as we know, delta H is very less than H1, and delta H is very less than H2. Delta H is very less than H1 and very less than, so neglect delta H. If you neglect delta H, then what will happen beta? Neglect delta H, then what will happen? PG value will come equals to, इसको इस साइड ले जाएंगे, rho mgh2 minus rho gh1. Clear है? Now H1 is a fixed value. अरे भाई ये जो हाइट है ये तो एक फिक्स वैल्यू है ना, फॉर अ गिवन मैनोमीटर, for a given single column manometer, H1 value is always fixed. तो H1 value तो fixed है. Only what is variable here? H2. Only one variable is there, my dear student, and that is H2. ओनली H2 इज अ वेरिएबल। क्लियर है? H2 को मेजर करो, फॉर्मूला में रख दो, आंसर आ जाए। H2 मेजर करो, फॉर्मूला में रखो, आंसर आ जाए। नो नीड टू मेजर नंबर ऑफ यूनिट, ओनली वन यूनिट। सपोज यू आर गिविंग दिस manometer to someone else, right, who is not engineer. So what he will do, he will go and he will attach that and he will just measure H2 value and then he put in this formula, H1 already known, H1 हम मेजर करके देंगे उसको। क्लियर है बेटा? So this point is clear. If anyone have any confusion, then tell me. Even for gases you can make it more simpler. Even for gases you can make it more simpler beta. Even for gases you can make it more simpler. कैसे? Now what I'm going to do is that for gases rho is very less than rho m. For gases क्या होगा? गैस का रो कितना होता है? Let's say air is there, air rho is 1.23 rho m. Let's say rho m is mercury is 13.6 into 10 to the power 3. So that also can be neglected. In case of gas, rho also can be neglected. If rho will be very small, then this value will be also very small. So Pg value will come rho mgh2 only. लो और सिंपल कर दिया मैं, और सिंपल फॉर गैसेस। अरे सर आप तो बहुत टैलेंटेड है, थैंक यू वेरी मच। आई एम वेरी टैलेंटेड, वेरी गुड, आई एम वेरी टैलेंटेड। और किसी को कुछ नहीं समझ में आया तो बोलो। अरे समझ में आ रहा है चंपक? समझ में आ रहा है? Are you able to understand? You are not considered atmosphere. Yes, beta. That's why I'm writing here gauge pressure. I'm calculating gauge pressure. That's why I'm not considering atmospheric pressure. Who is asking this? Who's asking this? Yes, Amarjit, Hemant. Clear. सारा लोग को clear है. Okay. So this column. Now here also one problem. See. This is basically used for very high pressure measurement, right? Very high pressure measurement. But here one more thing. So this is basically single column manometer. This equation I written here. So all these notes today I'll give you the notes beta, because actually this topic is not over. Not over earlier. So yesterday this topic was not over. So if I give half notes, then it's meaningless now. So today I'll give you the notes. So single column manometer is a modified form of U2 manometer, which is okay, same thing, right? Same thing. So here you can see that this is H1 is a fixed value, yeah? The delta H, and all these things you have, right? So here also I can write the equation for you. So this is a PA I want to measure, PA, okay, अरे वो सब लिख चुका हूँ यार, दोबारा लिख के time waste नहीं, I don't want to waste your time, okay? So this is single column manometer is done. So for any variation in pressure, the change in liquid level in reservoir will be so small that is neglected, and pressure is indicated approximately by the height of the liquid column in other limb. यही हम चाहते थे. That only I want. I just want that only one reading should require, so that normal people also can use this. Okay, and notes में दे देता, don't worry. Now coming to another point, that inclined type of manometer, right? So inclined, why we are using inclined type? Anyone can guess that why we are using inclined single column manometer? Why we are using inclined column manometer? I just want answer from you, then I'll give you chocolate. Today I have chocolate, right? This is the chocolate, right? This is the lollipop of my son, right? So I'll give you that lollipop to you. सर बहुत लॉलीपॉप दे रहा है आप हम लोगों को, हैं? देखो 2 लॉलीपॉप है, 3 लॉलीपॉप है मेरे पास, 3 लॉलीपॉप है, 3 लोगों को आज लॉलीपॉप मिलेगा, जल्दी बताओ. आई एम अनेबल टू फाइंड टेलीग्राम चैनल. अरे गो एंड सर्च. अरे भाई कोई टेलीग्राम चैनल उसको बता दो यार, नवीन को. कोई कमेंट बॉक्स में दे दो यार, प्लीज सेंड पेस्ट कमेंट बॉक्स टेलीग्राम चैनल. Just search शिवम दीक्षित 63. Just search शिवम दीक्षित 63. अरे भैया कोई दे दो यार इसको, नवीन को. Please someone give the this channel link to Naveen. For small measurement in industrial use. Okay. Low column height. Okay. To avoid use of high column. Oh, you are wrong, Pratik Sharma. Very large reservoir. No. No, 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 Champak. No, Champak. आज चंपक हो क्या तुम? और ये बताओ, तुम लोगों में से किसने सेशन लाइक नहीं किया? 36 people are there but only 26 likes are there. 36 people are there but only 26 likes are there. It means some 10 people are not like the session. I don't appreciate this. I don't appreciate this. Okay, now I will tell you. Now I will tell you, beta. See, it is basically, most of the people said the correct answer, that it is basically used to measure the very small pressure, right? Compared to atmospheric pressure, if pressure change is very small compared to atmospheric pressure, let's say atmospheric 1.01 bar, right? Now you want to measure 1.05 bar, right? You 1.05 bar or 1.1 bar, for example, you want to measure. So in that case, one problem will come. What is the problem? That this height, whatever this height in single column manometer, I'm telling you, this height is going to be very small. This height is also going to be very small. Or delta h be small, this height is also going to be very, when this height will be very small, when this height will be very small, then problem will come what in measuring that height. Some measuring error will be there, then actually you will not able to measure the correct value, correct? Because suppose this is very small, let's say this is very small, this height is very small, and it is in mm, let's say it is a 5 mm, but during measurement you are doing some mistake, let's say you did a 2 mm mistake, so it will be 7 mm, you are measuring 7 mm, for example. Then what will happen? Then all the calculation will be wrong. So whatever answer you will get, that will be 100% wrong. So what I'm trying to say, if the measured pressure is very small, my dear student friend, when the measured pressure is very small compared to the atmospheric pressure, means it is just above the atmospheric pressure, in that case what will happen? The height of column, height in another limb is going to be very small, and then chance of measurement error will be more. So that's why we are suggesting here to go for inclined manometer. How this inclined manometer will help you, that I will let you know, that I'll tell you. Let's say from here I want to start from PA, pressure is PA, I'm starting from PA, correct? I'm starting from PA, so now I'm moving downward, right? I'm moving downward, so up to here I'm moving. So how much plus will be there? That is rho, this is, let's say, rho, right? Rho g h1 plus delta h, okay, fine, h1 plus delta. Now I'll jump from here to here, okay? Now I'm moving upward means rho m, sorry, this is rho m, this is rho m, so rho m g. Now it is h2 or L. Should I write L or should I write h2? Tell me, should I write h or should I write h2 plus delta h? Obviously this is also delta h. Filling the blanks, यहाँ पे क्या आएगा? What will come here, बेटा? रत्नेश, शुभांकर, सिद्धनारायण, सिद्धू, पुलकित, नारायण, प्रतीक, सिद्धार्थ, राजू, लिख above. High sensitivity, error and less. Okay, L आएगा. Very good. L आएगा. Very good. अभिजीत, very good. अभिजीत यादव. हेमंत, very good बेटा. हेमंत, very good. L आएगा, correct है. अभिजीत एल आएगा, वेरी गुड, करेक्ट है। यस, ग्रेट ग्रेट ग्रेट, बहुत टैलेंटेड लोग हैं भाई। और जल्दी जल्दी बताओ, जल्दी जल्दी बताओ, जल्दी जल्दी बताओ। बोलो बेटा, बोलो बेटा, बोलो बेटा, बोलो बेटा, बोलो 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 बोलो। It is a pure watcher. Isn't सर अमरजीत नेम है। अमरजीत ही तो बोल रहा हूं मैं। क्या बोला मैं? अमरजीत ही तो बोला। एल साइन थीटा, वेरी गुड। अभिजीत बोला, ओके अभिजीत, सॉरी अमरजीत। ओके, सो हियर बेसिकली व्हाट विल कम, H2 विल कम। जितने लोगों ने L बताया रॉन्ग, whoever said L, that is wrong. H2 will come, my dear student friends, because whatever formula we studied, that is rho GH, P is equal to rho GH, P is equal to rho GH. In that one, H is the vertical distance basically. H is a vertical distance. क्लियर है? सपोज, अरे ये तुमको हर चीज का एग्जांपल देना पड़ता है। सपोज दिस इज लाइक दिस, राइट? नाउ अरे you started from here, right? You want to measure pressure here, so you are going to do like this? No, always you have to measure vertical distance only. Always you have to measure vertical distance only. Don't forget this. Yes. What is H2 value? H2 is L sin theta. This is theta, na? H2 is equal to L sin theta. So in place of H2, you can write L sin theta. Okay? L sin theta. What is the benefit? I'll tell you. Just wait, Champak, my dear students. Okay. Now, delta H is very, very less than H1, as well as delta H is very, very less than H2. So neglect delta H. Neglect delta H. Just like previous case, neglect delta H. So you are getting this is equals to 0. This I am measuring what? I am measuring gauge pressure. So PA plus rho G H1 minus rho mg H2. H2 means L sin theta. So basically you are measuring what? You are measuring L distance, but you are using L sin theta. समझ में आया? L measure कर रही, L measure कर रही, L measure कर रही, लेकिन use कर रहा है L sin theta. सर बेनिफिट क्या है? बेनिफिट I'll tell you. Let's say this theta is 30 degree. Let's say this theta is 30 degree. Sin theta is 1 by 2. Sin 30 is 1 by 2. Sin 30 is 1 by 2. If you are using single column manometer, if you are using what? If you are using vertical column, if you are using vertical column, then let's say height is coming 1 meter. Height is coming 1 meter. So here L value will be, if you are using 30 degree inclined, then what will happen? It will be L sin theta means L sin theta will be 1 meter. L sin theta will be 1 meter means L value is going to be 2 meter. 2 meter. मेजर कर रहा है 2 मीटर, मेजर कर रहा है 2 मीटर, बट यूज हो रहा 1 मीटर. सो मेजरमेंट एरर का प्रॉब्लम सॉल्व आउट हुआ कि नहीं? Let's say somewhere if you are using vertical column manometer, then height is coming 5 mm. What 5 mm? So in measurement of 5 mm or 6 mm, let's say it is range of 5 mm, right? So in measurement there may be problem. So you do it what, you make it 30 degree. When you make it 30 degree, the same pressure in frame, say deflection value will come 10 mm. This deflection value will come 10 mm. So you can easily measure. Clear है शंभुनाथ? शंभुनाथ clear है? Yes, great. So this can be used here, this can be used equal to 0. Clear beta? Any confusion? Let me know. This is an inclined single column manometer. Okay, then shall I move to the, and actually inclined one term is defined here. One term is that is called as sensitivity. One term is defined that is called as a sensitivity. What is sensitivity? Sensitivity is defined as the ratio of actual length to the effective length. Effective length is h2 only. Effective length is what? Here you can say actual sensitivity. Let's say I am representing in the sensitivity is equal to it is actual length. Actual length कितना है? h है, l है. Actual length is l. Actual deflection is coming l, and it is h2. So this value will come l by l sin theta. So it will come 1 by sin theta. So for vertical column, I can say that sensitivity value will come how much? Sensitivity value will come, vertical means theta value will be 90. Theta value will be 90. Sin 90 is 1. So sensitivity value will come 1. And for inclined, this is theta value equal to 90. For inclined, right, theta value is less than 90. So this sensitivity value will come greater than 1. So it will work on, अरे 0 तो नहीं ले सकते ना? कौन बोला? कौन मैक्सिमम एंगल पूछ रहा है? पठान हो यार तुम, हाँ? हाउ, सी वेरी सिंपल थिंग है. देखो वर्टिकल तो वर्टिकल एक, राइट, वो तो उससे ऊपर तो 90 से ऊपर जा नहीं सकते, राइट. यू कैनॉट गो बियॉन्ड 90. यू कैनॉट गो 0 ऑल्सो. अरे 0 करते तो मैनोमेट्रिक फील्ड बाहर चला जाता. समझ गए? इसमें मैनोमेट्रिक फ्लूइड है ना, मैनोमेट्रिक फ्लूइड. इन दिस वन, इन दिस मैनोमेट्रिक फ्लूइड इज, इफ यू मेक इट 0 इज बेस्ट. 0 value will come on infinite sensitivity. If theta value is 0, then infinite sensitivity will be there. देखो, अरे पूरा फ्लूइड ही बह गया. वेस्ट. क्लियर है? दिनेश, आदर्श, सिद्धार्थ, बालाजी, अमरजीत, ऋतिक यादव, कलाम सर, हेमंत, प्रतीक, आज बहुत नए नए लड़के हैं भाई, क्या बात है. राजू प्लीज शेयर द, प्लीज सर टेलीग्राम लिंक. अरे टेलीग्राम लिंक दे दो भाई, कोई क्यों परेशान कर रहे हो इसको? 100 मैसेज कर चुका, टेलीग्राम लिंक दे दो. पंकज, इफ डायमीटर ऑफ लार्ज मरकरी इज मोर देन क्या 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 पूछ रहे तुम? पंकज हुड्डा, if diameter of a large manometry is more and more, the accuracy in our system is high. Yes, correct. Hence can we use measure low, very low pressure differences? No, low pressure difference का बेटा समझो, accuracy will be better, but in low pressure measurement the in another limb, whatever small limb है ना, छोटा वाला limb, right, small limb, in that one whatever deflection will come, that will also very very small now. So in measurement error will be there, basically measurement error will be there, nothing else. Otherwise your observation is correct only, your observation is correct. माला लगड़ी कच्ची उकड़ी ओ माला इल्लापू, ये क्या है? हैं सार्थक कौन सा लैंग्वेज यूज कर रहा है तुम? माला लकड़ी कुल्ला पुच्ची पता नहीं क्या है। यूट्यूब कमेंट्स में कोई लिंक पोस्ट नहीं हो सकता, दिखता नहीं है। ओके ओके प्रतीक शर्मा, आई डोंट नो, आई डोंट यूज यूट्यूब मच, आई डोंट यूज यूट्यूब मच, only I use from 7:30 7 o'clock to 8:30 o'clock. Clear है? Shall I move to the further? Okay, we'll solve one problem on this. Just solve this problem beta. Everyone solve the problem and immediately you will get this 3 chocolates flavor I have, sorry, 3 lollipop flavor I have. A strawberry, mango, and this one is what? Blueberry. It is a blueberry, something like, right? So 3 flavors I have, and if you answer correctly, you will get 1. Sir, have you visited Assam? Number of times, Siddharth. Assam is very, very, very good place to visit. My brother is working in Assam only. My brother is in Air Force. My brother is in Air Force. He is in Assam only beta. दो तीन बार गया हूँ असम। आईआईटी गुवाहाटी में काउंसलिंग के लिए भी गया था। आईआईटी गुवाहाटी में थर्मल नहीं मिला था। आई गॉट मैन्युफैक्चरिंग इन आईआईटी गुवाहाटी। आई गॉट मैन्युफैक्चरिंग इन आईआईटी गुवाहाटी। So that is like that. Okay, very good. गेट कैसे क्लियर करे गोविंद कुमार? वेरी गुड. गोविंद कुमार is asking very interesting question that how to clear the gate. Very simple. पढ़ाई करके और शिवम सर को फॉलो करके. वेरी सिंपल. पढ़ाई करके और शिवम सर को फॉलो करके. वेरी गुड. इस पावर चला गया? नहीं, पावर तो आ रहा है. पावर तो आ ही नहीं रहा है, मतलब पावर नहीं आ रहा है, इन्वर्टर चल रहा है बेटा. आज पावर नहीं आया लखनऊ में, मतलब फ्रॉम लास्ट 3-4 hours there is no power in Lucknow. Why? Because rain was there and my area some of the trees are fallen down, like कुछ गिर गए. शिव चौधरी सर थोड़ा छोटा छोटा न्यूमेरिकल कराइए एसएससी जेईई. डोंट वरी शिव चौधरी, एक स्पेशल सेशन आएगा, एक स्पेशल सेशन आएगा. इन दैट सेशन आई विल ओनली सॉल्व द प्रॉब्लम, छोटा छोटा प्रॉब्लम. आई विल सॉल्व द चिन्ना चिन्ना प्रॉब्लम. आई विल सॉल्व द चिन्ना चिन्ना प्रॉब्लम. दीजिए सर लॉलीपॉप. आंसर बता दिया मैंने. सार्थक, सार्थक तुम्हारा आंसर इसलिए नहीं, इसलिए तुमको चॉकलेट नहीं मिलेगा. परसेंटेज कौन लिखेगा? 0.2 क्या होता है जी? 0.2% लिखो ना. 0.2% लिखना चाहिए. लॉलीपॉप नहीं मिलेगा तुमको, कोई लॉलीपॉप नहीं मिलेगा. तुमने 0.2 लिखा. 0.2 इज करेक्ट आंसर, बट परसेंटेज भी लिखना ना. यूनिट इज वेरी मच इंपॉर्टेंट. नेक्स्ट टाइम, ट्राई फॉर नेक्स्ट टाइम. Sir, you know Telugu? Yes, koncham koncham I know. Solve this, otherwise I will pagalguttu. Huh? I will pagalguttu you. मैं तुमको तोड़ देता. pagalguttu. मुझे दीजिए. शांतनु मंडल, लखनऊ का टिकट बुक करो. शांतनु मंडल, अमरजीत यादव, राइट. सर ये दुख क्यों खत्म नहीं होता? बेटा दुख एक ऐसा चीज है ना, वही है सुख होने का मजा देता है. जब तुम दुख झेलोगे ना, तभी खुशी मिलेगी. अब मान लो दुनिया में दुख ही ना हो तो फिर सुख का भी कोई मतलब नहीं ना. देयर इज नो मीनिंग ऑफ सुख ऑल्सो. फिर कैसे पता चलेगा कि सुख है कि नॉर्मल लाइफ है? तो लगेगा नॉर्मल है सब कुछ, और क्या. सो whoever is given the correct answer, just book one flight from their home to here. कम टू हियर. एयरपोर्ट में आके मिलता हूं मैं. घर पे नहीं आना, मेरे घर पे नहीं बुलाता मैं. एयरपोर्ट पे आके मिलता मैं तुमको, तुमको देता मैं ये, और उसके बाद रिटर्न फ्लाइट. ठीक है, श्योर करेंगे शिव चौधरी, डोंट वरी, आई डू इट। पैसा दीजिए टिकट करने का, पैसा होता तो यूट्यूब में पढ़ा रहे होते, पैसा ही तो नहीं है यार, बहुत गरीबी आ गई है मुझ पे। आज के दिन में क्या होता है, 200-400 करोड़, 2-4 करोड़ में क्या होता है आजकल, बहुत गरीबी आ गई है। I have not enough money to go. That's why. This is the motivation. You don't have enough money to travel. मेरे पास ट्रैवल का टाइम नहीं है, तुम्हारे पास ट्रैवल के लिए पैसा नहीं है। देखो ट्रेजेडी, देखो ट्रेजेडी, राइट? You can go somewhere, but you don't have money. I don't have time. कितना प्रॉब्लम है। घर पे तो आना है सर, घर पे आने के लिए कंडीशन है यार, एक्चुअली घर पे आने के लिए कंडीशन है, रैंक का should be in between greater than 0 less than 101. This is the condition to enter in my house. Whenever you come to my house ना, so एक device मैं लगाया हूँ, in that device they will ask that what is your rank, then you have to put that rank, then only door will open. तो सर आपको तो कभी इस रेंज में आया नहीं, तो आपको कैसे एंट्री मिलता है? मेरा कुछ जुगाड़ है, मेरा घर पे जुगाड़ है, घर की जो मालकिन से है ना, उससे मेरा जुगाड़ है, कोई प्रॉब्लम नहीं। But you have better life than me. अरे don't think like this beta. If you are thinking that, believe me, this is my 110% correct words, that if you are thinking that your neighbor have better life than you, or Ambani have better life than you, it's not true. It's not true at all. The day when you will get great job, whatever your expected job is there, right? अभी देखो, have you watched one video 317 rank, 317 rank, that is video, I put it, name क्या था उसका, I forget the name. 317 rank एक वीडियो पढ़ा है ना, मेरा स्टूडेंट है वो, so he got ONGC, right? He got 5 PSUs, he got 5 PSUs and he selected ONGC. After 2 years, even when he joined at that time, his dream job was there, ONGC, but after 2 years he left. After 2 years he left, बोले सर मजा ही नहीं आ रहा, लाइफ ही खराब हो रहा है। Then he joined NIT Mumbai, again he studied for 2 years, then again he got placed some big company, I forget the name. So don't think like this beta. Nice device. सर मैं हैक कर लेता, देखो मैं डिवाइस हैक कर लेता, देखो। ओके बेटा, ओके ओके ओके, प्लीज सॉल्व। ओके, द क्रॉस सेक्शन एरिया ऑफ लिम्ब, one limb in YouTube manometer is 500 times larger than, okay, so capital A by small a value is 500 basically. Now between two limbs can be determined by measuring h on one limb and percentage error with respect to the pressure measure. Okay, so actually we are measuring what? Actually we are measuring h. We are measuring h, but we should measure h plus delta h. We should measure h plus delta h, right? So basically error will come, how much? Error value will come delta h. Error value will come, no, 1 minute. Actual height is equal to h plus delta h. Measured height h only. Measured height is h only. So error value delta H. So percentage error. So delta H by H into 100. Now apply volume conservation. I already told you A into delta H is equal to A into H small a, right? So basically delta H by H is equal to A by A. That is nothing but 1 by 500. Put this value here. So you'll get 1 by 500 into 100. So this value will come 0.2%. Clear है? सर एक प्रॉब्लम हो रहा है दत्ता immediately start test series. That is the only way. If you are feeling that it is taking more time, to solve the problems and all, please start the test series. Test series is the only way to increase the speed. Only test series, nothing else. Test series start karo. Yes. Okay, differential measure, YouTube manometer, inclined YouTube manometer, micro manometer. Okay. चलो जल्दी जल्दी ये सब भी आज बता देता हूं और आज खत्म करते हैं प्रेशर. Today we will finish this pressure. And tomorrow we'll start with the not tomorrow. अच्छा एक यार बहुत बैड न्यूज है. बैड न्यूज ये है कि 2 दिन की मैं छुट्टी ले रहा हूँ. Tomorrow and day after tomorrow is holiday. Because day after tomorrow one big puja is there. In my village, right? In my village one big puja is there. That is a Mahalakshmi puja. So I am going for that purpose. So tomorrow I will leave from Lucknow. And Sunday afternoon I'll come back. So Sunday evening session will be there. Beta. Okay. Now I'll tell you this differential manometer is similar concepts are there. It's very easy, right? For example, let's say this is a pipe, right? This is a pipe, and in this one, at this section some pressure is there, and in this section some pressure is there. Later on you'll get to know in pipe flow chapter that pressure gradient in direction of flow is always negative. For a pipe flow, listen here statement. This will prove this later. Statement is the pressure in pipe flow, the pressure gradient is always negative in direction of flow. Means in direction of flow, pressure is keep on decreasing because of friction. Okay. So I want to measure the pressure difference here. This is the section 1 and this is the section 2. I want to measure the pressure. So what I'm going to do? Here I'll attach one manometer. Here also I'll attach one another manometer. Manometer means piezometer. Sorry, not manometer, piezometer. I'll use 2 piezometers. So here it will record some height na. It will record some height beta. So it will take this particular height. Now this height is, let's say from center I'm measuring. So this is basically H1. Now this height will be obviously less because here pressure is less. So this will be H2. So here pressure is, let's say P1. Here pressure is, let's say P2. What is P1 value beta? P1 value rho G H1. What is P2 value beta? Rho G H2. Now this difference is known as what? Delta H, for example. This is H I am writing. H. So basically H is equal to H1 minus H2. Now I want differential manometer क्या होता है? What is differential manometer? Differential manometer is measuring the pressure difference between 2 points. Differential manometer is basically measuring the pressure difference between 2 points. Simple manometer is measuring the pressure at a point. Okay. So basically I can say that P1 minus P2 I want. So P1 minus P2 value will get a rho G. I'll take it common. H1 minus H2, that is H. So P1 minus P2 is equal to rho GH. So what you have to do, if you want to measure the pressure difference between 2 points, just use 2 piezometer and find out the level difference in both the limbs, right? Both the piezometer, that is H, then you use rho GH. Very simple. This is the most simple, but again problem is there. If pressure difference is very big, if pressure is very big, so very big size of piezometer required. That is one problem. Another problem is, suppose inside the pipe what is there? Gas is there. Inside the pipe gas is there. If inside the pipe gas is there, तो gas अगर piezometer लगाते gas उड़ जाता, right? So you cannot use it for gas. Okay, very simple concept. Then come to the YouTube differential manometer. So two arrangements are possible. That's why I drawn these two. Same equation will be this. This is first diagram. This is second diagram. So here pressure is, let's say, P1. Here pressure is, let's say, P1. Here pressure is, let's say, P2. P1 minus P2 I want to find out. This is, let's say, rho 1. This is rho 2. This is rho m. Manometric fluid. ठीक है. So start from P1. I'm writing equation for first diagram. So I'll write P1. Now I'm going downward means plus rho 1 GH1. Then I'll jump from here to here. Then minus rho m GH, reach here. Then minus rho 2 GH2 is equal to P2. We can find out P1 minus P2 from here. We can find out P1 minus P2. So our aim is what? Our aim is to find out P1 minus P2. With the help of YouTube manometer also, you can find out the, suppose two chambers are there or two containers are there. If you want to measure the pressure difference, आ गई power. Yes, very good. Power came. Now, so if suppose मैं फैन ऑफ कर देता हूँ, अदरवाइज यह आवाज करेगा अननेसेसरली. मैं फैन ऑफ कर देता हूँ 1 मिनट. तब तक आप सेकंड का इक्वेशन लिखिए. For second case, I can write here. Same equation will come basically. So this is, let's say, P1. This is rho 1. This is P2. This is rho 2. Is right? Okay. So P1 plus rho 1 GH1 minus rho m GH minus rho 2 GH2 is equal to P2. So P1 minus P2. Same equation. So like that you can use same thing. Correct hai? So basically it's about two containers are there, right? Let's say two container, again power gone. Maybe they are checking, right? So let's say two containers are there, and if you want to measure the pressure difference between these two, then you can use this YouTube manometer. Clear hai? Next one is inverted YouTube differential manometer. Now, you know what is the problem here? This one is used for very high pressure difference, very high pressure difference, right? Means between 1 and 2 pressure difference is huge. Right? Pressure difference is huge, then only you can use it. Suppose in 1 and 2, in P1 and P2, the difference is very small. Then if pressure difference is very small, then can you use this one? And if you cannot do, then why you cannot do? Please listen here. Actually, you can use this. Suppose P1 or P2 in P1 and P2, the difference is very small. So what is problem is going to come like, problem will be like here it is a mercury now. It is a mercury. Right? Let's say it is a mercury. So if it is a Hg beta, then deflection will come very small. इतना small कि आपको शायद पता भी ना चले. right? इतना small की पता भी नहीं, listen, right? So if, because see here the row of manometer is very very high than row 1 and row 2, row, right? Row m is greater than row 2. clear है, समझ में आया आपको? Row m value is very very high compared to row 1 and row 2. That's why if very small pressure difference will be there, then deflection, this h value, this h is going to be very very small. This h is going to be very very small, and then you will not able to measure it properly. Then you will not able to measure. Sir, one idea I have, one idea I have, one idea I have. What is the idea? What is the idea? Sir, I will use, listen here, listen here. I will use the manometer. I will use the manometric fluid. I use the manometric fluid which have low density. Low density. If low density will be there, high deflection will come. Low density will be there, high deflection will come. But one problem is there again. One problem is there. Suppose let's say remove the, प्लीज लिसन हियर केयरफुल. ये कोई बुक में नहीं मिलेगा तुमको, कोई बुक में नहीं, मतलब बुक से में मिलेगा लेकिन बहुत ढूंढना पड़ेगा, राइट? इट्स वेरी डिफिकल्ट टू गेट फ्रॉम बुक. प्लीज लिसन हियर. सपोज लेट्स से रो 1 इज greater than rho m, right? And rho 2 is also greater than rho m. Means I am using some manometric fluid. I am using some manometric fluid which density is very very low. Which density is very very low. Let's say some oil or something I'm using. Some oil I'm using which density is very very low. In that case what will happen? If less dense is there तो क्या होगा? ये तो इसके अंदर चला जाएगा ना. अरे भैया इधर देखो. Now please listen here. Suppose here we have a water. Here we have a water, right? Water. और अगर oil डालेंगे तो oil तो ऊपर आ जाएगा ना, right? If suppose water, if I put here oil, then oil will be coming at top now. Why? Water will be below. Water will be below, oil will be up, because oil density is less. So here also same thing is going to happen. If I put, if rho m value is less than rho 1 and 2, then this will enter here, this will enter here, ये नीचे आ जाता. समझ में आ रहा है कि नहीं आ रहा है? अरे ये बात क्लियर हुआ कि नहीं? This point is clear or not? If rho m value is less than rho 1 and rho 2, if rho m value is less than rho 1 and rho 2, then ये मरकरी क्या होगा? इसके अंदर घुस जाएगा. मरकरी नहीं, सॉरी, manometric fluid. This manometric fluid will enter here, this manometric fluid will enter here, and then you will not able to measure. So for that purpose what I'm going to use, I'm going to use inverted U2 manometer, differential manometer. Number of time people are asking that why we are using inverted U2 manometer, because ये light liquid. अब अगर मान लो ऑयल को यूज करें, मान लो ये वाटर, लेट्स से दिस वाटर, दिस इज वाटर, दिस इज वाटर एंड दिस इज ऑयल. अरे भैया water, this is oil. If it is oil, then what will happen? Then it will work, but in this case it will not work. If it is, this is oil, this is oil, this is oil, sorry, this is water, this is water and this is oil. तो oil क्या होता? Oil container के अंदर चला जाएगा, oil container के अंदर चला जाए, oil will enter into the container, but here oil will not into the container. So why we are using this? Why we are using inverted U2 manometer? Why we are using inverted U2 manometer? Very simple logic, very simple logic, that we are using to measure very small pressure difference, right? Used to measure very small pressure difference, right? And this is rho, right? Rho m, right? So this is the rho 1, this is the rho 2, this is rho 2. So I can say that rho m is less than rho 1 and rho m is less than rho 2. क्लियर है बेटा? समझ में आया? इतना डिटेल में कोई पढ़ाता है क्या? इतना डिटेल में कोई पढ़ाता है क्या? कभी पढ़ा इतना डिटेल में? बात करते हैं. Okay, so this is a light fluid. So why we are using inverted U2 differential manometer? To measure the very small pressure. So light liquid यूज करेंगे, तो light liquid यूज करेंगे तो ये H वैल्यू क्या आ जाएगा? बहुत ज्यादा आएगा, बड़ा दिखेगा. मेजर करने में कोई प्रॉब्लम नहीं होगा. Now write the equation fast. This is let's say P1, this is let's say P1, this is let's say P2, this is let's say P2, this is let's say P2. So this value is given like P1 and here we have P2. So I can write like P1 minus, we are moving upward, right? When we are moving upward means negative sign will come. So negative rho, this is let's say rho 1. So I can rho 1 GH1, rho 1 GH1. Then I'll jump from here to here. Then I'll jump from here. Now I'm moving downward. Downward means plus. Downward means plus. Rho M G H, then again plus rho 2 GH2 is equal to P2. You can find out P1 minus P2. Actually P1 ज़्यादा है, P2 कम है. Clear है? Any confusion? अरे कुछ भी confusion है बोलो भाई, कुछ भी confusion है बोलो भाई. If anyone have any confusion, please let me know. If anyone have any confusion, please let me know. ठीक है? So we will stop today here. This topic is over. This topic is over. In some days, some more question will practice once fluid static will over. Okay? So actually one more topic is there, that is micromanometer. But believe me, my dear student friend, it is a somewhat difficult. But over difficult, actually it is not asked in this GATE. So it is not important for GATE purpose. It is not important for GATE purpose. It is actually used to measure very small pressure difference with very high precision. ये micromanometer is basically used for research purpose. Correct. So I used to teach this for IES student, and even if it is a long term batch full length course, then I used to teach this. But believe me, it is not important for GATE. It is not important. That's why I'm skipping here. I'm skipping this, and this is skipping this, and I will teach this part in plus or even some special class also if you want. I will teach, no problem. But for time being, I am leaving this. Okay. All other topic I already teach. All other okay. And this part also I'm not question I will solve. This Borden gauge, right? This is also not important for GATE. It is only for ESC and for your knowledge. So Borden gauge and this strain gauge sensor, piezoelectric pressure transducer. So these things I am not discussing. So basically, theoretical point of view, it is completed. Theoretical point of view, it is completed. Some of the questions are there that if time will permit, then I will solve. If time will permit, then I will solve. So officially, beta, officially, otherwise I will give you these questions. I will give you these questions, and you just solve by your own. If any doubt is there, you can ask in Telegram. You can ask in Telegram. Clear है? The solution भी दे दूंगा मैं. Question, solution both I will give you. I'll give you both question and solution. ठीक है? तो कर लेना. So this is all about today. So I am telling you, there is one batch which is already started in 8th of September. 20% discount is going on. Tomorrow this 20% discount is going to over. Tomorrow this 20% discount is going to over. So if you want to use, if you want to purchase this Unacademy subscription, then you have to use code Shivam101, Shivam10. Not only you, your family, your friend, your anyone, right? Then after that, from 22nd onwards, from 22nd onwards, one my fluid mechanics is going to start on plus. So if you want to take the benefit of this, then you have to enroll, and you have to enroll now, today itself or tomorrow. Tomorrow is the last day for this offer. Okay, so you can use either plus or iconic. These are the benefits basically, right? Then you have to use Shivam101. This is a fee structure of plus as well as iconic. Comparison you can see, right? EMI option is also available. Now this is the someone is asked me that, sir, what was the thing. So here we 5 person, right? 5 person is going to launch one batch, right? We are going to launch one batch on YouTube, and that batch name is Let's Crack GATE in 90 days. Let's crack GATE in 90 days. Let's crack 18th. We will give the detail. 18th one session is there. In that session we will give you the detail. 18th we will give you the detail about this one. that in that detail I will tell you the schedule also. All the complete syllabus will be covered. Marut sir is going to take design subjects. Marut sir and Alok sir is going to take design subjects. Our Raju sir is going to take production and industrial subjects. I am going to take thermal fluid heat transfer, and Pallo Jha sir is going to take mathematics. All the subjects and aptitude, mathematics aptitude, design subjects, SOM, design, engineering mechanics, STOM, production industrial, thermal, heat transfer and fluid mechanics. All the subject will be covered in approximately 350 hours. In 350 hours, all the topics is going to cover in beautiful manner. So if you want to take the benefit of this, be connect with us, right? So 18th को हम लोग date wise announce करेंगे. In 18th we will announce the schedule also. Schedule भी announce करेंगे, सब कुछ announce करेंगे, ठीक है? So say thank you and say bye. Okay, thank you beta sir. Very small density का relation कैसे होता है? Okay, I'll tell you. अरे रो जी एच ना बेटा, रो जी एच. If suppose P is equal to rho, if density will be low, H will be high. अरे G तो फिक्स है ना. अरे G फिक्स है बेटा, G फिक्स है. इफ रो कम होगा तो H ज्यादा होगा, रो ज्यादा होगा तो H कम होगा. वेरी सिंपल. P is equal to rho G is constant, G is fixed. If rho value will be more, then H value will be less. If H value will be more, then rho value will be less. Very good. अरे यार मेरे क्या हो गया, मैं समझ में नहीं आ रहा है कि JLEE में रोज भूल जाता हूँ यार. JLEE क्या रहता, मुझे कुछ समझ में नहीं आ रहा. एक मिनट में अब भी देख लेता, मैं पहले देख लेता JLEE क्या है. So whoever is already completed, like सबका हो गया अगर सेशन, ठीक है. अच्छा ये मत भूलो, एक स्कॉलरशिप टेस्ट भी है. देयर इज वन स्कॉलरशिप टेस्ट ऑन 18th at 11 a.m. Don't forget it, because you can get MacBook, you can get iPad, you can get mobile, you can get 1 crore rupees also, like 1 crore gift. So this is all about, don't forget this, okay? So you know all this thing. The joint lateral entry exam, third semester of BTech, Assam Engineering College, Jorhat Engineering College. Beta, is it related to the BTech admission program? Who is saying that? Who is asking? Thank you, sir. भूलने का बीमारी मुझे भी है. भूलने का बीमारी मुझे भी है. Okay. Siddharth, is it related to BTech admission? Okay, is it related to BTech admission? So joint lateral entry for this one, Assam Engineering College, Jorhat Engineering College is quite good college. Okay, let me tell you this one. If I'm not wrong, beta, Siddharth, acha, you already completed diploma, you want to get that. Okay, if I'm not wrong, then definitely these classes are going to help in your selection in this JLEE. JLEE के सिलेक्शन के लिए डेफिनेटली ये यूजफुल होगा बेटा, मैं 90% श्योर हूं. बट एक बार मुझे सिलेबस और देख लेने दो. अगर आप हो सके तो मुझे सिलेबस भेज दो यार. तुम मुझे व्हाट्सएप नंबर है मेरा, टेलीग्राम पे भेज दो. टेलीग्राम पर्सनल भेजना, ग्रुप पे नहीं. और जो सिलेबस भेज दो मुझे, बस मुझे सिलेबस हो जाए. और अगर हो सके तो एक आध क्वेश्चन पेपर अगर मिल जाए तो, अगर क्वेश्चन पेपर मिल जाए, इफ यू हैव क्वेश्चन पेपर और सिलेबस, प्लीज सेंड दिस. You don't have syllabus also, you don't have question paper also. If you have question paper or syllabus, please send. Even some of my students are there from Johrat Engineering College. Some of my students are there from Johrat Engineering College. One student from Johrat Engineering College is doing, I think, PhD from UK. Okay, forget about WhatsApp number, beta. You just share in Telegram. You just share me in Telegram. Okay. सिद्धार्थ, मैं कोशिश करता हूं पता करने की, कुछ स्टूडेंट से भी पता करता हूं. ठीक है. Okay, say thank you and bye. Should I send you Telegram? Yes, please send in Telegram. Please send in Telegram. Say thank you and bye. And if you want to take Unacademy subscription, then take today also, today only or tomorrow, right? And use Shivam 101. Okay, thank you. Okay, bye bye, beta, bye bye.